Now for the next question, students were asked to talk about the process of osteoclast bone resorption. Okay, so what is osteoclast bone resorption? So it's something that students always talk about when they are trying to talk about all those rickets, osteomalacia, all those weak bone stuff. But most students don't really know what osteoclast bone resorption is. Yeah, Aravind, I actually see you, bro. So it's actually a process by which osteoclasts are multinucleated giant cells. They break down bone tissue, they release calcium and phosphate into the bloodstream. That's just introduction, right? We get to talk about the normal process and when disease conditions could actually harness this process to actually cause damage to us. So it's a normal physiological mechanism for bone remodeling. Okay, your bone has to be remodeled. So bone tissue come up, but later on it's being broken down, new one forms, remodeling. All right, but it can become excessive. Okay, and if the level of breakdown of the bone tissue is not being balanced up with the level of formation, it can lead to bone loss, bone weakness, lead to fractures. Okay, so let's go on. So first of all, we'll talk about the mechanism. First of all is osteoclast differentiation. So it's derived from monocyte and macrophage lineage. Is stimulated by the receptor activator of the nuclear factor what KB ligand, that's RANKL. Okay, and the macrophage colony stimulating factor produced by osteoblasts and stroma cells. That's stimulation. The process is inhibited by what? Osteoprotegerine. So two things kind of like control the process. So attachment to bone surface. So osteoclasts adhere to mineralized bones via what? Integrins. They will form a sealing zone that isolates the resorption area. Okay, formation of ruffled border. So specialized membrane with proton pumps and enzymes. It creates an acidic microenvironment. Okay, then bone matrix degradation. So acid secretions, that's like hydrogen via carbonic anhydrase too, would dissolve hydroxyapatite crystals. So proteolytic enzymes are also involved. They degrade collagen and organic matrix. So now the calcium and phosphate will now be released into what? Circulation. Okay, it's not really an interesting something, and they'll hardly ask you this in an exam, but probably when you watch this video you understand it better. So physiological role, it helps in bone remodeling, it helps in calcium homeostasis. So it maintains the level of calcium in the body, level of calcium, okay, in the blood, calcium in the bone. So adaptation to it allows bones to adapt to mechanical stress. Okay, so this process of bone breakdown and remodeling, it could get too much, resulting into disease conditions which we are interested in. Okay, so that's why they will actually want you to know this. Okay, so it could actually lead to osteoporosis, where the osteoclast activities is too much, your bones are fragile. It could lead to hyperparathyroidism. It could lead to Paget's disease of the bone. Then sometimes cancers can harness this whole process to cause a lot of issues to you. Okay, then inflammatory arthritis too. Okay, so I think that's it for this. Okay, it's not quite an interesting thing, but if you know it, you know the basis. Okay, so you can discuss any bone weakening condition from the basis. Okay.